going to be a short video explaining how to graph by rewriting it in function form and then using an input-output table, an XY table. So step one is to rewrite it in function form, right? Now, what does function form mean? It means get y by itself. So obviously, here's your equal sign. You don't have y by itself. There's a plus 5. So you're going to get rid of that plus 5 by doing a minus 5 and a minus 5. Now, you cannot actually do 3x take away 5. It's not like negative 2x. You can't subtract a number from a letter, right? You got 3 x's and you want to take away 5. It's like saying I got $3. I want to take away 5 bananas. It doesn't work, right? So we're just going to rewrite it. So we now have y by itself equals, and we're just going to rewrite this 3x minus 5. So here's our function form equation. Y equals 3x minus 5. Everybody's cool with that, right? Now, from there, step two is to make an input-output table, in-out table. And we know that an in and out table looks like this. The x's are your inputs, the y's are your outputs, okay? And on the instructions, I say most of the time, you could plug in 3 easy numbers like 0, 1, and 2. So let me explain what this means. Let me actually show my work this time. I haven't been showing my work in class here. When I plug in a 0, where am I going to plug it into? Into the x. All these numbers are on the x side of the table. So we're going to plug in all these numbers into x. So here's 0, here's x. I'm going to plug it in. Now, I've been doing this in my head. I go, plug in a 0 right there. 3 times 0 is 0. 0 minus 5 is negative 5. But let me actually show my work. I'm going to rewrite this guy. Y equals 3 times x minus 5. And notice that instead of x, I put parentheses because I'm going to plug in that 0 right in there. Now, at some point, you're going to get so good at this that you could do it in your head or on a calculator. By the way, you could just type this in exactly the way it is on a calculator, 3 times 0 with parentheses, take away 5, hit equal, and it'll give you the answer, the output, negative 5. 3 times 0 is 0. 0 minus 5 equals negative 5. So your y value is negative 5. So when you plug in the x value of 0, your y value comes out negative 5. So that is a coordinate, okay? Now, again, this work that I'm showing right here, you should be able to do that in your head or on a calculator. But right now I'm just showing it so you guys could completely understand what's going on. I'm now going to plug in a 1. I plug in a 1 into the x, and it's going to say y equals 3 times 1, plugging it in with parentheses, minus 5. So what I have here is 3 times 1, that's 3. 3 minus 5, that means y equals negative 2. So when I plug in a 1, I get out a negative 2. Again, this work right here, you should be able to do it in your head or on a calculator. And last but not least, I'm going to plug in 2. So my equation would read y equals 3 times x, but that's times 2 because I'm plugging in a 2 where the x is at. And then it does say minus 5, so I have a minus 5 over here. Now doing the math, 3 times 2 is 6. Again, you could do all this on a calculator, and 6 minus 5 is 1. So when I plug in a 2, I get out a 1. We have the 3 points. 0, negative 5 is down here. Then we move on to 1, negative 2. That's 1 on the x, negative 2 on the y. Well, that's 1 on the x, negative 2 on the y right there. And last but not least, 2, 1. 2 on the x, 1 on the y. It's right there. And we have our 3 points that line up perfectly, which means that we're confident we have the right graph of the line. If you wanted to, you could take the pattern from one point to the other and use that pattern to extend the line. From here to here, I'm going up 3 over 1, up 1, 2, 3 over 1. So if I wanted to make the line longer, I keep going up 1, 2, 3 over 1 and put a dot right there. So you can make this line as long as you want if you keep using that pattern of up 3 over 1. Anyway, that's how you do this. Now, again, this work that I did right here, actually plugging in and showing my work, you don't have to do that. You could do that work on a calculator, or you could do it in your head, right? 2 right there. 3 times 2 is 6. 6 minus 5 is 1. So when you plug in a 2, you get out a 1. Plug in a 1 right there. 3 times 1 is 3 minus 5. 3 minus 5 is negative 2. You get out a negative 2 when you plug in a 1. Let's move on to this next one. This next one's interesting. Step one is to rewrite it in function form. The y is definitely not by itself on the left side of this equal sign. The y has a -5 that's being multiplied with it, and it also has a -25 over here, all by itself. So you're going to get rid of both. What do I get rid of first? The -25. By doing the opposite, plus 25. What I do to one side, I do to the other side, plus 25. I'm going to rewrite this thing. The equal sign's here. What's left on the left side? A -5y. What about the right side? I have a 15x plus 25. You cannot add those together. You can't add x's with numbers. You could add x's with x's, bless you, but we don't have x's with x's. We have 15x plus 25, so we're just going to rewrite that. 15x plus 25. Final step to get y by itself would be to get rid of this multiplication of -5 by dividing by -5, dividing by -5, dividing by -5. When you're adding and subtracting, you could only add or subtract like terms, but when you're multiplying or dividing, you could multiply or divide anything. They don't have to be x's with x's or numbers with numbers. You could divide x's with numbers. You could do anything when you're multiplying or dividing. Anyway, we have function form y equals a function form equation. Y equals -3x minus 5. This is step one, writing our function form equation. Is everybody with me? Okay, now let's move on to step two, which is making an input-output table, an XY table, okay? Now, I said most of the time you're gonna use 0, 1, and 2, but check it out. If we use 0, let's do this work in our head this time, or type it into a calculator. 0 plugged in right there, it would be -3 times 0 minus 5. Like I said, you could type it in into a calculator, right? The way it is, -3 parentheses 0 minus 5 hit equal, it'll give you the answer -5. Of course, you don't need a calculator. If you got it in your head, plug in a 0, -3 times 0 is 0. 0 minus 5 is -5. So when you plug in a 0, you get out a -5. That is a coordinate. Let's go to that coordinate 0, -5. 0 on the x, -5 on the y. That's going to be right there, right on the edge. If we move on to plugging in 1, I said most of the time 0, 1, and 2 are great. But in this case, when you plug in a 1 right here, let's do this in our heads. What is -3 times 1? That's -3. What is -3 minus 5? You owe 3, you owe 5, you're going to owe 8. Now, that is a point on this line. That is the correct answer. However, if you go to 1 and -8, man, you're way off this graph, right? The graph's not big enough. That doesn't mean that it doesn't exist. It's there for sure. I mean, it's like down here somewhere. So yeah, the line goes that way. But if you know it's off the graph, then what you got to do is plug in inputs that will be on the graph. So obviously, if you plugged in a 1, you got out a -8. If you plug in a 2, you're going to get out something more negative. Plug in a 3, it'll be even more negative off this graph. So what would be a good number to plug in if you want it to go on this side? Well, a -1 would be a good number to plug in. Does that make sense? So let's plug in -1. And when you plug in a -1 right there, what's -3 times -1? A negative times negative, positive. So that's +3 minus 5. What's +3 minus 5? -2. If you're confused with that, use a calculator, right? You could type in exactly the way it is, right? -3, parenthesis, plug in your -1 right there, and then -5, hit equal, it'll give you the answer -2. So input -1 gives the output -2. So where's that location? -1, -2. -1 on the x, -2 on the y, it's right there. You see, it does line up with that dot that was off the graph, but this is the one that is on the graph. So if you wanted another point on this graph, what would be a good input to plug in? -2 would be great, right? Now, I could already see that if I plug in a -2, my answer is going to be a 1 without doing any math. How do I know that? Because I already see the pattern here. From this point to that point, it's down 1, 2, 3 over 1. So backwards is backwards 1, up 3, backwards 1, up 1, 2, 3, and that will be a dot right there. Now, what does that actually mean? That if I did plug in a -2, I would get out a +1, because -2, +1 is that coordinate using the pattern. If you don't believe me, let's plug in a -2 right here. -3 times -2 is a +6. and positive 6 minus 5 is a positive 1. Cool? All right. So right here, this was a good example where we didn't use 0, 1, and 2. We used 0, but 1 was off the graph. So you might need to use different values like a -1 and a -2, right? Anyways, those are the 3 coordinates. You draw your line, put some arrows on it, and you're good to go. If you wanted to make the line longer, keep going with that backwards pattern of backwards 1, up 3, backwards 1, up 1, 2, 3. You could put a dot there, make it even longer if you want. Let's take a look at this next one. Here's another one where 0, 1, and 2 are not the best x values, okay? Let's get y by itself. You're going to get rid of that multiplication of 2 by dividing by 2, dividing by 2, dividing by 2. So you're going to have y equals 3 halves x minus 4. We now have it in function form. But when you go to an input-output table, 0 always works. Let's always use 0. Check it out. When you plug in a 0, it's beautiful. Anything times 0 is 0. And in this case, 0 minus 4 is -4. Super easy, right? 0, -4, right there. 0 on the x, you don't go left, you don't go right, you stay at the origin, and -4 on the y, put a dot there, that's 0, -4. Now, if I plugged in a 1 into this function form equation, if I plug in a 1, that's going to be not nice. What do I mean by not nice? Because 3 halves times 1 is 3 halves, and 3 halves minus 4, you need a common denominator, or you need to deal with fractions. You could type it in the calculator, but you're going to get a fraction as an answer. And obviously, it's better to have nice integers as answers instead of fractions. Okay, so instead of using 1, whenever you have a fraction in front of x, is very important. Everybody pay attention. Whenever you have a fraction in front of x, it'd be good to use the denominator of that fraction since you're multiplying. And we know that when you multiply a fraction with its denominator, it cancels out the fraction. So what would be a good input to use? That denominator, which is 2. So it'd be good to use the number 2. Let me show you how that works. Let me rewrite it over here. Y would equal 3 halves times, if I plug in a 2 right in here and then have a -4 at the very end, you could do it on the calculator, or you could just cancel it out and you have 3 take away 4, which means that y equals -1. So when you plug in a 2, you get out a -1. Okay, so the thing to remember with this example is if you have a fraction that's being multiplied with x, instead of using 0, 1, and 2, always use 0. That'll get rid of anything. But instead of using 1 and 2, use the denominator and maybe double the denominator, or maybe the negative denominator. Okay, so another good input to plug in would be doubling the denominator, making it a 4, or maybe a negative denominator, making it a -2. Those are good inputs. So if I were to plug in a 4, let me show my work right here. I'm going to show plugging in a 4. It's y equals 3 halves, plug in a 4, then you have the -4. So when you plug in a 4, you could use a calculator, or you could be like 4 divided by 2 is 2, and 3 times 2 is 6, and you have 6 minus 4, which is 2. So y equals 2. The input 4 gives you the output 2. The x value of 4 gives you the y value of 2. Or you could have rewritten it and plugged in -2, the negative denominator. Y equals 3 halves times -2 minus 4. So you could plug in the negative denominator. That would have canceled out the 2's, but then you got 3 times -1. That'll be a -3. And -3 minus 4, that would be a -7. So when you plug in a -2, you get out a -7. Anyways, when we plot these points, you'll see that they do line up. 2, -1. 2 on the x, -1 on the y. It's right there. And then we have 4 on the x, 2 on the y. 1, 2, 3, 4, 1, 2. Put a dot right there. And as you can see, they do line up. If I did go -2, -7, -2, -5, 6, 7. Oh, 6, 7. So it's still on the line, as you can see, right? What do you guys think? Great. So as we can see, an XY table is a way to keep track of the numbers that we're plugging in and getting out. We plug in numbers into the x values. The x values are also known as inputs. And then we get out answers that are our y values. Those y values are also known as outputs. And that's very important information on the next section. But right now, we need to practice graphing by rewriting it in function form, getting y by itself, and then by using an input-output table to come up with some coordinates. So we have an assignment to do. It's on Google Classroom. Let's get started.